the IRR rule, the internal rate of return rule or approach. This is the fourth investment valuation approach that we are learning in Chapter 9. This is another important alternative to the net present value, the NPV approach. It's very often used in practice, actually, in the business world, and it can also be intuitively explained very easily. Let's look at the following example. You're considering an investment with the following cash flows. In year 0, you would be investing $10. Maybe it's all in millions, right? Then in year 1, your profit would be $6. In year 2, $5. In year 3, $8. And in year 4, another $8. So these are our cash flows for this 4-year investment project. What do we want to do with them? Well, let's calculate the net present value. Okay, let's start with the net present value. And then you're going to see the link between the net present value and the internal rate of return approaches. To calculate the net present value, normally we would need to also know some discount rate, right? Well, it's not given here. So let's calculate the NPV for several more or less randomly picked discount rates. Let's try 30%, 50%, and 70% for our discount rate. And then one question we're going to answer is, at which discount rate do we break even? So let's not worry about the second question yet. So we want to calculate 3 net present values, right? Separately at a different discount rate R. If you want to do it by hand, then the NPV would equal -10 plus 6 divided by 1 plus R, where R can be either 30% or 50% or 70%, plus 5 divided by 1 plus R squared, plus 8 divided by 1 plus R cubed, plus another 8 divided by 1 plus R to the 4th power. Or of course, you can do it in the financial calculator. Cash flow case, one step. You enter cash flow 0 as -10, cash flow 01, 6, cash flow 02, 5, cash flow 03, 8, and cash flow 04, also 8. And then when it asks you for the I, that's your rate. So that rate, you will first try 30, right? And then compute NPV. And when you try the 30% discount rate, your NPV will be $4.02. Then when you redo the whole thing and instead try the 50% discount rate, your net present value will be 17 cents. And then when you try the highest discount rate of 70%, your net present value is -$2.15. So let's illustrate it in a more visual way, what is going on and what the results mean. If we put the discount rate on the horizontal axis, right? So as we move to the right, the discount rate is increasing. And then for each discount rate, we calculate the net present value. And that's what we have along the vertical axis. So above the horizontal axis, the net present value is above $0. That's a good thing. That's when we say the project should be accepted. But if we are below the horizontal axis, that's where the net present value is below $0. And that's when we say reject the project. So when we tried the 30% discount rate, the net present value was $4.02. That's above 0, and we plot this point above the horizontal axis. Then when we instead picked a higher discount rate, 50%, the net present value dropped, and it's now only 17 cents. So close to 0, right? And then when we tried a randomly picked even higher discount rate, 70%, that's when we saw an even smaller net present value. And in fact, it was a negative number, -$2.15. So if we tried a few more discount rates, then we would keep adding more and more points. And all of them could be connected with this downward sloping curve. We call it the NPV profile, the net present value profile. So this downward sloping line shows that the higher the discount rate, the lower the net present value. And this is something we actually had already in chapters 5 and 6 a long time ago, where we saw how the higher the interest rate, the lower the present value, right? And present value of all future cash flows is a big part of the net present value calculation. So the net present value profile is a graphical representation of the relationship between the net present value and various discount rates. And it's a negative relationship because the line slopes down and to the right. Now, see this blinking point here. That's where this net present value profile crosses the horizontal axis. What does this point mean? It means that at this specific discount rate, and we don't know yet what it is yet, the net present value is how much? It's exactly $0. And that's the meaning of breaking even. We break even. We neither make money nor lose money. The net present value is neither positive nor negative. It's exactly 0. And we can actually figure out what this specific discount rate should be in order for us to break even. There is a way to calculate it, and if you know that trick, you will find that it's 51.2%. So in the previous calculations of the net present value, if you use 51.2% for the discount rate, the cash flow keys will give you the NPV of exactly 0. So 51.2% is the internal rate of return, the IRR. The meaning of the word internal means that this rate of return on our money every year is only based on the so-called internal information about this investment project. And that internal information is the cash flows that are given. So if we invest $10 now, we get 6 back in a year, another 5 back in 2 years, then 8, and then another 8, right? So we only used the cash flows, right? The money invested and the money that would be received to figure out what it all implies about the annual return on our money, an annual return on the $10 that would be spent now. So that's why it's called internal rate of return. So you can think of a much simpler example. Let's say you invest 10, you get 11 back in a year, and that's it. There are no more years in the future. So if you invest 10 and get 11 back in 1 year, that's obviously a 10% return. That's also the IRR. The IRR is 10%. So here it's more complicated. It's a 4-year project, right? And so it's more tricky to calculate that sort of implied, fixed annual rate of return on our money, the same return every single year for 4 years. And it turns out to be 51.2%, right? So if you invest 10, you get 6 and 5 and 8 and 8 back. And the IRR sort of connects what you spend with what you receive. So what you spend kind of equals in today's dollars what you receive across all future years. That's why the difference between the present value of all future cash inflows and the cash outflow today is 0. The NPV equals 0, right? So you kind of break even. Okay, so IRR is nothing but a discount rate, but it's a special discount rate. It's that discount rate at which, when you calculate the net present value, you get exactly $0. So at this rate, we break even. We make neither profit nor loss with our investment project. So the internal rate of return definition is it's the discount rate at which the NPV equals 0. And it's called internal because it's based entirely on the estimated cash flows for future years and the estimated required initial investment today. And it's completely independent of other sort of external things, such as the typical rate of return on this kind of projects that was, observed by other companies somewhere else. Now, okay, how do we calculate the IRR? Well, there is always the trial and error approach. It might take a while, and the idea is you try, plugging in different discount rates, and you stop when the NPV is 0. But of course, our lifesaver will be the financial calculator. Let's learn something new. If you look at the second row of our calculator, Texas Instruments BA2+, you will see the button IRR. It's right next to the NPV button. So IRR is the internal rate of return. And let's learn how we use it. What we do is, let's take out our financial calculator. Let's turn it on. Let's start by clearing everything. Second, plus minus, enter. Off and on again. Imagine you're calculating the NPV. The first several steps are identical. You start by pressing the cash flow key in the second row. Cash flow 0 is the initial investment, which is -10. So you press 10 plus minus, enter, it's saved. Then you press the down arrow key. Cash flow 01, the first cash flow in the future, that's 6. 6, enter, down. What's the frequency of it? F01. The default is 1, and that's also the case in our example, because $6 is not repeated in the second year. It's only once in a row. So we leave the frequency as 1, and you can either save it by pressing enter and then you press the down arrow key, or you can immediately press the down arrow key because 1 is the default number. So I'm pressing the down arrow key. And then the same way I'm entering cash flow 02, $5, cash flow 03, $8, and cash flow 04, $8. So the second cash flow in the future is 5. I press 5, enter, down, and the frequency is again left at the default value of 1. I press the down arrow key. Cash flow 03, that's $8. 8, enter, down. Here I can speed things up a little bit and change my frequency to 2. I press 2, enter, down. And if I do this trick, then there will no longer be cash flow 04 because that was that second $8. Then normally if you're calculating the net present value, you would press the NPV button. The display will ask you what's the value for the I, which is the rate. You would enter that and press compute, right? To find the internal rate of return, you do something different. You press the IRR button and then you press compute. So after entering all cash flows where you would be pressing the NPV button, now instead you press the IRR button and compute. 51.20, right? So 51.2% per year. That's the annual return on our money, on the $10 that we would be investing in this project if we decide to accept it. Okay, let's go back to this graphical illustration of what's going on. How are we going to use this IRR approach to make our investment decision? And we are talking about in which case would we say accept the project or reject the project? Well, we have just calculated the internal rate of return. So we would be making a 51.2% return on our invested money every single year, right? If the required return, and that's the so-called external number, right? Something that is given in addition to the cash flows, right? Let's say the required return is 40%. So the required return is 40, but we are going to make a better return, 51.2% every year. So does that make our project a good one or a bad one? A good one. And so in this case, when the required return is less than the IRR that we have calculated, then we say that the project should be accepted. Otherwise, if the required return, which is a number that's given, right, is more than the IRR that we have found, then the project should be rejected. There's another way to intuitively explain this conclusion. Whenever the required return is to the left from the IRR, that's where on our graph the net present value line is above the horizontal axis, which means the net present value is above $0, which is a good thing. And instead, when the required return that's given to us is greater than the IRR that we calculate first, then that corresponds to the part of our graph where the NPV line lies below the horizontal axis, which means the net present value is negative. And that's when we say reject the project. So the internal rate of return rule, to summarize, says that a project should be accepted if the required return is less than the IRR. Otherwise, it should be rejected. And, there's this very strong link between the IRR approach and the net present value approach. Because whenever a project is accepted using the IRR rule, that's when the net present value of the project is positive. So that's when we also say accept when using the net present value approach. And when a project is rejected using the IRR rule, that's when it's also rejected using the NPV rule, because the NPV is below $0. So the only calculation we do to use the IRR approach is, in one step, the cash flow keys in our financial calculator. So we use the cash flow keys to find the IRR, nothing else. And the second step is we compare the IRR that we found with the required return, so-called required return, which is a number that's always given to us. So we just check whether our IRR is above or below the required return. If it's above, that's a good thing. Accept the project. Otherwise, reject it.